Tonight we're talking about significant figures. So significant figures are really important in measuring in the sciences and chemistry in particular, and they're used in order to demonstrate the precision of a measurement or a value. Significant figures are the numbers used to describe a value, and often consideration of decimals or decimal spaces is important when deciding on whether or not a significant figure is there or present, especially when it comes to zeros. In order to fully understand this concept of significant figures, we're going to go over their rules. So the rules of significant figures. Any non-zero number is a significant number or a significant figure. Zeros found between two non-zero numbers are also significant. The leftmost zero in front of non-zeros are not significant. They are called placeholders. Zeros at the end of a number and to the right of a decimal point are significant. Zeros at the end of a measurement and to the left of a decimal point serving as placeholders are not significant. These zeros are only significant if they are known measurement values. Quantities that have unlimited numbers of significant figures, quantities can have unlimited numbers of significant figures, such as counting, or that I have 12 beakers. So for some examples, 539 has 3 sig figs. Those are all non-zero values, so all 3 of those digits are significant. 4,083 has 4 significant figures. That 0 is sandwiched in between 2 non-zeros, and so it is significant. 0.000453 has 3 significant figures. These zeros right here to the right of the decimal, but before any non-zero, are considered placeholders. 590.5 has 4 sig figs because this 0 is to the left of the decimal. 390 has only 2 sig figs. You only have 2 non-zeros, and this 0 is not sandwiched in between anything. However, 390 decimal point has 3 sig figs because this 0 is to the left of the decimal point. Taking the average of 54.9, 55.0, and 53.2 yields 54.4 with 3 sig figs, even though the number is being divided by 3. So even though you're dividing by a number that only has 1 sig fig, you're still going to yield the correct answer of 54.4 with 3 sig figs, because quantities can have unlimited numbers of sig figs. So those are the hard and fast rules. Those can kind of be confusing to understand, which I totally get, and so I've got a little trick to teach you, and I learned this from Mr. Lockett. So here in front of you is a picture of the United States of America. On the right-hand side, we have the Atlantic Ocean. On the left-hand side, we have the Pacific Ocean. So here's your Atlantic Ocean, symbolized by the A, and your Pacific Ocean, symbolized by the P. The A here stands for absent, and the P stands for present. And that absence or presence is considering the decimal point. So let's go here, and I'm going to write a number up here. Alrighty, so 101,000. Sorry guys, this is not the most clean I've ever made anything. So 101,000. And the question is, how many sig figs does this have? And we could go back and refer to the rules, or we could use Mr. Lockett's trick. And the trick that Mr. Lockett teaches us is that on the absent, when a decimal place is absent, starting from the right side of the number, because the Atlantic Ocean is on the right side of the United States, you go right to left and you stop when you hit a non-zero. That first non-zero is your first significant digit. So we started over here at the right, and we drew a line and drew an arrow until we got to a non-zero, which was that 1. That 1 is our first significant digit. So this 1 right here is our first sig fig. First sig fig. Okay? Then anything to the left of that first sig fig is considered significant. So anything to the left is also significant. So 101,000 has 3 sig figs, okay? Alrighty, so that should help you a little bit over there. Now let's wander on over to the Pacific side, or the present side. And so this is for any time you have a decimal place that is present. So if we had 0.03720. So the question then is, how many significant figures does 3720 have? And so again, because we're now on the Pacific side of the United States, or the left-hand side, we're going to start from the left and go until we see our first non-zero number, which is 3 here. This 3, our first non-zero, is our first significant digit. Okay? So 3 is our first significant digit. First sig fig. This 0 and this 0 are not significant. They are to the left of that 3, and we started at the left-hand side because we're on the Pacific side, and we went to find that first significant digit, or that first non-zero, which is our first significant figure. Everything after that first sig fig is considered significant. So 372 and this 0 are considered significant. So for the value of 0.03720, there are 4 sig figs. Okay. And that's just a nice little trick that Mr. Lockett showed me on how to, instead of having to memorize all 6 of those rules, which are good to know and understand, I'd like you to still have read them and listened to them, but this is a nice little trick to help you apply that and to help you to remember those rules. So I need to go back and get rid of all of that. Sorry about that. Clear objects. Alrighty. So now we're going to start calculating with significant digits. A calculated answer cannot be more precise than the least precise measurement it was calculated with. So that's a really important thing to take into account when we're talking about sig figs. If we're trying to calculate using significant figures, we cannot have an answer that is more precise or has more significant figures than the values that we use to calculate it. So therefore, calculated numbers have to be rounded. And remember, rounding numbers, if it's greater than or equal to 5, you're going to round it up. And if it's less than 5, you're going to round down. So for addition and subtraction, using significant figures, the answer should be rounded to the least number of decimal places you have. So for example, and I'm going to give you an addition and subtraction example at the same time. I'd like you to add together 12.52, 349.0, 8.246, and find out what that answer is. And then I'd like you to subtract from 649.27, I'd like you to subtract 3 and 21.290. Please pause the video while you do this addition and subtraction. You should be pausing. Alrighty, thank you for pausing. Now compare your answers to the answers that I get. So for the addition problem, you should have a total of 369.766, and for the subtraction, you should have 624.980. Now the question is, how many sig figs do we write this as if we're trying to do the correct number of sig figs? Think about that for a minute. Pause the video for a second to maybe review some of your notes, aka the note above there that says that it should be rounded to the least number of decimal places. Alrighty, and for sig fig wise, 369.766, the answer here, 349.0 only goes to the 10th place, so our answer can only go to the 10th place. Therefore 7 is where we have to stop. 6 is greater than 5, so you're going to round up 7 for a total of 369.8. On the subtraction side, your total is 624.980. Your 3 only goes to the ones place, and so you can only have to the ones place for your answer. So 624.9 can only be written to the 0.4, which 9 is greater than 5, so 625 is your answer. Sorry, 624.9. 9 is greater than 5, so you have to have 625. Alrighty. Oh, whoops. Alrighty, moving on. Multiplication and division. When multiplying and dividing numbers with sig figs, the answer should be rounded to the least number of significant figures. This has nothing to do with decimal places, and instead this time works on sig figs. So I would like you to look at these two examples. 7.55 times 0.34. Take out your calculators, do that. And pause the video. Alrighty, so that is 2.567. Now if you look at 0.34 using our USA model that Mr. Lockett taught us, we can see that we have a decimal point present, so we need to start from the left and go along until we hit our first non-zero value, which is that 3, and so from there we can see that we have 2 sig figs. So the answer 2.567 needs to be rounded to 2 sig figs, so 2.6. Alrighty, 2.4526 divided by 8. Go ahead and pause the video and calculate that. Alrighty, so now that you've paused the video and calculated it, let's compare our answers. The answer is 0.306575 using Mr. Lockett's hint. What is the least number of sig figs out here? And this one you don't even need a hint for. 8 only has 1 sig fig. So we need to write the answer as 1 sig fig. However, this 0, using Mr. Lockett's Pacific Coast, because we have a decimal point present, going from the left, that 0 is not significant, so we don't stop until we hit 3. So that's going to be our first sig fig. That's the only sig fig that we include. If you look at that 0, it is less than 4, so we're going to leave 3 as it is. So our answer is 0.3. Alrighty guys, thank you for talking about sig figs. I'd like you to now take the time to go and watch the accuracy and precision video, unless you watch the accuracy and precision video first, and then in that case go to bed, go have fun, go eat dinner, do whatever, and I'll see you tomorrow.